Hey everyone, welcome to this lecture on vector analysis. For this video presentation, we'll be discussing um, gradient of a scalar function. So last three videos natin, we are discussing yung mga integration ng scalar and vector functions. So ngayon naman, pupunta tayo sa differentiation ng mga scalar and vector functions. Of course, as we might expect, in addition to the need to integrate yung mga scalar and vector expressions na meron tayo, we also need to differentiate. And yung rules and implications of these operations, yun yung i-discuss uh, natin and considered to the study of electromagnetism. We have three types of operations sa differentiation ng mga scalar and vector functions. Yung first natin is yung gradient, gradient, okay? Then followed by divergence. Then yung third natin is yung curl. So, yung mga symbols na gagamitin natin dyan, uh, malalaman ninyo sa mga susunod na video presentations. Although sa ngayon, bigyan ko na kayo ng hint, ito yung ginagamit natin ng mga symbols. So, yung first, which is yung gradient, nire-relate niya yung mga scalar functions. Tapos yung divergence naman and curl para sa mga vector functions. Okay? So, siguro simulan na natin yung gradient of a scalar function. Yan. So, we define the gradient of a scalar function to be the vector which gives both magnitude and direction of the maximum spatial rate of change of a scalar function is called gradient of a scalar function. So, ibig sabihin pala, pag kinukuha natin yung gradient ng isang scalar function, ang result nun is a vector quantity. Okay? So, uh, imagine you are standing dito sa parang cliff na to, no? So, dito sa zero, let's say, dito kayo. And then, itong cliff na to is parang inverted mountain na pinakamalalim dito sa ibaba. Yung slope, ng uh, ng object na to at any given point, maaaring hindi yan defined. Okay? Unless we qualify with something like the slope in the northeast direction, o kaya the slope in the direction of a particular region, no? Or a similar statement. Also, maaring depende kung ang i-describe natin na slope nitong cliff na to, kung pataas yan o pababa. Pwede rin kasing gusto nating mahanap is yung slope na pababa or yung slope na pataas. It depends. Okay? Bakit ba natin kailangan yun alamin? Okay? So, kailangan natin siyang alamin kasi when we are designing yung mga ganito, for example, kailangan natin yung slope kung pataas, importante sa mga nagdi-design ng mga building na kung saan, let's say, mga civil engineers, when we design yung mga roads, ang interesado tayo or we might be interested doon sa daan or sa path in which yung ating slope is minimum no? Yung maliit yung variation ng slope. Kaya naman ah, dito natin magagamit yung gradient. Okay? Okay, ulitin ko lang yung definition ng gradient. The vector in which gives both the magnitude and direction. The vector which gives both the magnitude and direction of the maximum spatial rate of change of a scalar function is called the gradient of this scalar function. Okay? At any given point of this function, there is one direction which is unique. Ito yung maximum slope. Kaya interesado nating makuha yung um, gradient. Itong direction na to, uh, associated to dun sa properties ng mga vector fields or scalar functions, lalong-lalo na sa electromagnetism. Okay? So hindi ko na i-derive yung formula, no? I will present it to you here. Yan. Ito yung ating tinatawag na gradient. Okay? Gradient of a scalar function. So sabi nga natin, ang result ng gradient of a function is a vector quantity. Kaya mapapansin natin dyan, meron tayong x hat, y hat, and z hat, yung mga unit vectors natin in the x, y, and z components. Plus, ano to? Ano yung expression na yan? It is the partial oops, partial derivative of a function u with respect, let's say x, y, z, ano? With respect to x. Okay? So, ibig sabihin, kukunin natin yung partial derivative ng buong uh, function ng scalar function, no? Meron tayong scalar function represented by u. Kukunin natin yung partial derivative niyan with respect to x para yun yung ating magiging scalar component. And then sa y, ganun din. Then sa z. So, ang importante dito sa pagkuha natin ng mga gradient is yung function, yung scalar function. Okay? And of course, yung mga differentiation formulas natin sa differential calculus. No? So, importante nating malaman yon. Okay? Siyempre, pagka ganyan, yan. Although, itong formula natin na to, tama naman yan. No? Yan yung ating magandang definition. Pero marami kasi na gumagamit ng ganitong notation. Okay? Yung iba, gumagamit ito tinatawag nilang grad u. Okay? The gradient of a function u, scalar function u. Ginagamit nila tong operator na to. No? Ibig sabihin, inalis lang natin yung u, nilagay natin dito, and then ito naman is a operator. Okay? So, parang ulit lang siya, constant lang siya. Notation natin to indicate yung meron tayong operation na gagawin sa u. So, ang tawag natin dyan is the gradient of u. Yung quantity na nandito sa parenthesis is a fixed operator for any scalar functions na gusto nating i-evaluate yung gradient. And then, kaya naman meron tayong special na notation na ginagamit to indicate itong operator natin na to. Imbis na grad u, yung iba kasi ginagamit itong gradient of u. Okay. Grad u. Sa particular, sa US, ginagamit nila yan. Pero sa ibang bansa, Meron din namang ganito. Tinatawag natin na del, no? Ang basa natin diyan is del U. Okay? Del U, itong pula na to or itong symbol na to is, kung di ako nagkakamali this is a nabla. Nabla. Okay? So parang inverted na delta. Okay? So ganun siya. So pag binasa natin yan, del U is equal to itong operation natin na to of the scalar function. Okay? Itong del operator na to is a mathematical operator to which by itself, uh, wala siyang geometrical meaning. Okay? Ibig sabihin, notation lang natin yan to indicate that we are getting or going to operate a particular function to get the gradient. Okay? Yan. So, pakitandaan lang yung formula. Pinax ko lang para intense. So, the gradient has these general properties. So, first, it operates on a scalar function and results in a vector functions na banggit ko na to kanina. The gradient of is normal to a constant value surface. Okay? So ginagamit natin to identify kung saang direction yung vector field. Kaya lumalabas na sinusundan pa rin niya yung right-hand rule. Number 3, the gradient always point in the direction of the maximum change in the scalar functions. For example, in terms of potential energy, yung gradient, it shows the direction ng increase in potential energy. So dun siya usually nagagamit para makita natin kung merong changes or increase in the potential energy. So gradient yung ginagamit natin ngayon. Okay? So ayan. Try natin mag-solve ng mga problems related to the gradient. Okay? Gamitin natin, subukan naman natin i-recall yung ating differential calculus, pagkuha ng mga partial derivatives. Okay? So, start na tayo. So we have here a vector normal to the surface is del of a function in terms of x, y, and z, where the function is an equation of the surface. Consider the plane x, x, y, x plus square root of 2 y plus z is equal to 3. Find the vector to this surface and the unit vector to the normal to the surface. So meron tayong pinapahanap na vector, find the vector to this surface and the unit vector. So kailangan lang natin kunin is yung vector na yon, and then i-apply lang natin yung formula natin ng unit vector para makuha yan. Well, let's write yung equation na meron tayo, yung plane, which is the function equal to x plus the square root of 2 y plus z is equal to 3. O, siguro mas maganda ilipat na natin yung yung 3 sa kabila. Gawin na nating minus yan. Minus 3 is equal to 0. Yan. And sabi sa properties ng gradient, no? Para mahanap natin yung gradient ng plane na yan, it is based on the fact that the gradient is always normal to a constant value function. So for example, itong surface na to, pwede nating makuha yung vector ng surface or normal to this plane by getting the gradient. So let's say we have a vector A. Yan. Yan yung vector na normal to the plane. It is equal to yung ating del operator ng F. Okay? And it is equal to the del operator of x plus the square root of 2 y plus z minus 3. Okay? So, paano nga ulit natin ginagawa yung del operator? We are getting the partial derivative ng buo with respect to x. So, ulitin ko lang ulit ha. So, we know that yung formula natin, yan, pula natin. Yung formula kasi natin kanina, del of u is equal to x hat, partial derivative of u with respect to x, di ba? Plus y hat, the partial derivative of u with respect to y, plus z hat, partial derivative of u with respect to z. Yan. So yung u natin dito, itong equation natin na ito na nasa loob, so kukunin natin yung partial derivative. Okay? Kaya naman, ang mangyayari dyan is del f is equal to x hat. Ano yung partial derivative natin ng loob? No? So partial derivative ng nasa loob is actually ito magiging constant na yan. Ang matitira is 1. Kung di ako nagkakamali, ha? 1. Yan. Plus y hat, the partial derivative din itong loob na nasa loob. So, pag kinuha natin yung partial derivative niyan, ito magiging 0 plus yung y magiging square root of 2 na lang yan. Then plus 0 lang yan. Right? Plus z hat times the partial derivative ulit nitong equation natin na to. So 0 plus 0 plus 1 plus 0. Yan. So ang naiwan sa atin na del is del of f is equal to x hat plus y hat, the square root of 2, plus z hat. Okay? So yun yung ating a vector normal to the surface. So ito yung vector normal to the plane. Yan. Sensya na sa sulat ko ha. Hindi pa ako sanay sa pen na ginagamit ko. So to get yung ating unit vector, right? To get yung ating unit vector ng A, so we have A hat is equal to the vector divided by its magnitude. Okay? So in this case, gamit naman tayo ng pula naman para green, para maiba naman. It is equal to x hat plus y hat, the square root of 2, plus z hat all over the square root of 1 squared plus square root of 2 squared plus 1 squared. So, ano na ang sagot natin? Final answer natin, dito kasi ang sagot natin is 1 plus 2 plus 1 is 4. So, square root of 4 is equal to 2. Kaya ang sagot natin dito, x hat, then ang kanyang component is 1 half, plus y hat, the square root of 2 over 2, plus z hat, 1 half. Okay? So, yan yung ating sagot dyan sa problem na yan. Okay. So, let us note that the constant value in the equation is immaterial. Ibig sabihin nun, it does not change the slope in the x, y, and z direction. Okay? So, next. Tapos na tayo dyan. Buburahin ko na yan. Dito naman, sa problem natin na to, pinapahanap yung derivative of x, y squared plus y squared z at point 1, 1, 1 in the direction of the vector a is equal to x hat 3 plus y hat 4. Medyo tricky itong question na to, pero uh, sagutan natin. So, ang una natin gagawin dito is kukunin natin yung gradient nung function na to. And once na makuha na natin yung gradient, ang makukuha natin doon is yung directional derivative na in the normal direction. Then, we will evaluate yung gradient at point 111 and then we will find the projection of this particular vector into the vector A. So subukan natin gawin. Okay? So let's say that we have a vector V, or function or scalar function is equal to xy squared plus y squared z. Di ba? So pag kinuha natin ang gradient natin na yan, pag kinuha natin ang gradient ng V, gradient of V is equal to x hat times the partial derivative with respect to x. That gives us y squared plus 0. Tama? Then sa y hat naman, ang kanyang partial derivative is 2xy. So binaba ko lang yung 2 doon. Plus 2yz. Sana nakakasunod pa tayo dyan. Plus, sa z hat naman, we have 0 sa una plus y squared. Okay? Yan. So, rewrite lang natin ulit yung ating equation ng gradient. So, we have x hat y squared plus y hat 2xy plus 2yz plus z hat y squared. Okay? So, anong susunod? Sabi, kukunin natin yung gradient, diba? Find the derivative of this at point 111. So, we will substitute yung ating uh, point into the gradient. So, the gradient of V at point 111 is now equal to x hat times 1 squared plus y hat. Ito naman ay 2 times 1 times 1 plus 2 times 1 times 1 plus z hat 1 squared. Lagyan natin ng parenthesis. Okay? Simplify natin, we now have x hat plus, so sa y hat, we have 2 plus 2. We now have 4. No? We have y hat 4 plus z hat. Yan. So, the direction in the space, di ba? So, in the direction of A. So, kailangan pala natin yung direction ng A. So, we now need to get yung ating A hat para makuha natin yung direction, di ba? So, the direction of A, ang ibig sabihin niyan is we are going to get yung ating A hat. Okay? And then later, ang gagawin natin dyan is we will, para makuha natin yung projection, dyan, kukunin natin yung dot product. Okay? So, itabi lang muna natin yung ating del of V at 0.111. Mamaya, gagamitin natin yan. Kunin muna natin yung ating A hat. A hat is equal to A over the magnitude. So, ano yung A natin? X hat 3 plus y hat 4 divided by the square root of 3 squared plus 4 squared. So, ano yan? X hat 3 over 5 plus y hat 4 over 5. So, para makuha natin yung projection, no? Finally, to get yung projection of oops, our derivative on to a hat, kukunin lang natin yung dot product niyang dalawa na yan. Okay? Nakakangalay pala to. So, kukunin natin yung dot product, no? Para makuha natin yan, it is equal to, yung del natin is x hat plus y hat 4 plus z hat dot, yung a naman natin is x hat 3 over 5 plus y hat 4 over 5. Diba? So, anong sagot na natin dyan? Okay. Yung ating projection in the direction of A, right, yan, is now given to be 1 times 3 over 5 plus 4 times 4 over 5. Okay? Yan. Yan. It is now equal to 19 over 5. So, yan naman yung projection ng ating derivative sa direction ng A. Okay? So, yun yung ating sagot. So, lumalabas na yung ating slope nung scalar function na to at point 111 in this direction is 19 over 5. Okay? Sana nakasunod tayo dyan. Okay? Let's move on to the next. So, of course, pwede rin tayong, dahil meron tayong mga iba pang coordinates aside from Cartesian na kinoconsider, kailangan alamin din natin yung formulas to get yung gradient sa cylindrical and dun sa spherical. Okay? So, ano ba yung mga formulas natin na yan? So, for cylindrical, ito lang naman yan, no? R hat, then yung partial derivative ng function na nasa cylindrical coordinates with respect to R, and then plus phi hat 1 over R times the partial derivative ng u or function na nasa cylindrical coordinates with respect to phi plus z hat partial derivative of the function in cylindrical coordinates with respect to z. Okay, so yung z actually pares lang siya ng ano, di ba? Ng Cartesian, kaya ganyan na siya. Okay? And then sa cylindrical naman or sa spherical naman, ito naman yung ating formula. Ayan. R hat derivative of the function in spherical coordinates with respect to r plus theta hat 1 over r then times the partial derivative ng ating function in spherical coordinates with respect to theta plus phi hat, no, 1 over r sine theta times the partial derivative of the function in the spherical coordinates with respect to phi. So, yan. Nilagyan ko lang din ng box yan para intense. Pakitandaan na lang itong mga formulas natin na to. So, try natin mag-solve. No? Siguro isa, kahit isa. So, a scalar field is given in Cartesian coordinates as f, no? as a function of r, phi, and z is equal to r phi plus 3 phi z. We are to calculate the slope of this scalar field in the direction of vector A is equal to r hat 2 plus z hat. Okay. So, paano natin gagawin yan? Una muna, kukunin natin yung slope. Pag sinabing slope, ang kukunin natin is yung gradient, right? Pag kinuha natin yung gradient na yan, after natin makuha yan, kukunin in the direction, no? In the direction of this, parang pares pala to nung kanina, no? Kukunin ulit natin yung a hat, then kukunin natin yung, after natin makuha yung a hat, kukunin natin yung dot product ng dalawa na yon, yun na yung magiging uh, projection or in the scalar component in the vector A. Okay, so let's try. Let's try lang natin. So sabi, ang una natin kukunin is yung gradient or del f is equal to x hat times the partial derivative of the function with respect to x plus y hat times the partial derivative with respect to y plus z hat times the partial derivative with respect to z. Now, maganda sana itong formula na to kung nasa Cartesian. Kaya lang yung given kasi sa atin is nasa cylindrical. So, gagamit tayo ng ibang formula. In this case, we will use yung diniscuss lang natin earlier, r hat times the partial derivative with respect to yan, with respect to r plus phi hat 1 over r times sorry d sub f, partial derivative ng f with respect to phi plus z hat, partial derivative ng f with respect to z. So, yun yung gagamitin pala natin. Okay? So paano na yan? The gradient of our function now becomes r hat. Ano yung partial derivative with respect to r? Nito. Sa una, we have phi, right? Plus 0 plus phi hat 1 over r times partial derivative of the function f with respect to phi. So, una dyan is r plus 3z. Okay? Yan. Plus z hat, partial derivative ng function with respect to z. So, yung una natin, 0 yan, plus 3 phi. Okay? So, simplify muna natin. We now have r hat times or phi plus phi hat 1 plus 3z over r plus z hat 3 phi. Yan, ganda. Now, gagamitin natin yan mamaya. We want to get the direction, sense ng direction natin. So, we must solve first yung ating a hat. So, yan. Computing ko na ha. So, a, that's r hat 2 plus z hat over the square root of 2 squared plus 1 squared. It is equal to r hat 2 over the square root of 5 plus z hat 1 over the square root of 5. Yan. So we now have itong dalawa na to. Po-proceed na tayo dun sa pagkuha ng projection. Okay? Again, the projection, ang hinahanap dito kasi is yung projection. Okay, so del F dot A hat. So del F dot A hat is equal to, ano ba yung ating del? R hat phi plus phi 1 plus 3z over R plus z hat 3 phi dot, oops, R hat 2 over square root of 5 plus z 1 over square root of 5. Medyo ma-skip lang, no? Anyway, yan. It is now equal to, multiply lang, no? Phi times 2 over the square root of 5. So we now have 2 phi over the square root of 5. Tama? Yan. Plus, sa phi naman is actually 0 yan. 0. Kasi wala namang partner. Plus, the z naman is 3 phi over the square root of 5. Right? Therefore, simplifying this, we now have 5 phi over square root of 5. Ano ba? And normalizing this or irrationalize natin ito, it will now become equal din yan sa square root of 5 times phi. Yan. So, yung projection or the slope of our scalar function in the direction of A is equal to square root of 5 phi. Okay? I hope nakasunod tayo dyan. So, medyo sa gradient kasi, kailangan lang natin na knowledge is yung tawag dito, calculus natin para sa partial derivatives and yung kung merong basic sa dot product and para makuha natin yung direction. Okay? So, that's it. I guess, meron pa ba? And that's it for now for the gradient of scalar functions. Yung mga susunod kasi, divergence and curl, they are for vector functions or differentiation in the of vector functions. So, I hope meron kayo natutunan and makatulong to sa pag-solve ninyo sa mga problem sets sa LMS natin. And see you on the next presentation. Maraming salamat!